Hi, my name is Jhamieka Greenwood. I am second year now, starting in the fall, PhD student at Florida State University. Um, my usual work is on atmospheric fire interactions um, within wildfires, but during this internship, it was great to work with atmospheric science data and expand my knowledge on Python. And so throughout this internship, so I'm really into graphics computing. So it was great for me to work with Thomas Martin, my mentor, to do an overview of data visualizations with PyVista and Rapids. So first off, what is PyVista? So PyVista is a Python package, open source, that provides an interface to the visualization toolkit VTK. And so it's an easier framework that you can use that has built-in interactive visualizations than Matplotlib. And so it enables researchers to rapidly explore their data sets, communicate their spatial findings, and really like show their data using 3D computer graphics, image processing, and you can do a lot to facilitate your work using scientific visualization. So one thing when you're getting started with a new software package is installing it. So that was one of the challenging and fun parts of my internship, was getting everything installed and getting ready to work with it. So so it's for installing PyVista, so the only thing you need is Python itself. And I went through providing like the two pathways you can install PyVista, which is Conda, which is the easier way to install it using Anaconda, to make sure you have like the correct versions of everything for Python, any dependencies, any other packages that you would need, and then a quicker pathway to install is using pip install. And some of the pitfalls with installing PyVista was running into inconsistencies with the versions. So that's one of the challenging parts, and it makes it easier to use Anaconda. But with using this new package, just trying to make sure everything has the same version, everything is compatible. Yeah, it makes it easier to work with. And then next we have installing PyVista Xray. So in this internship was the first time that I've used Xray data sets and like on the Thread server. So on top of being introduced to PyVista Rapids, I was also introduced into like a new way of using data sets and everything and installing them. So this package made it very easy to be able to use the Thread data sets with PyVista. And same thing, all you need is Python and PyVista. You have two pathways to install it, Conda, using Anaconda, which is easier to make sure everything is compatible with each other, and quicker option is pip install. And then same thing with the pitfalls, just making sure everything is consistent with the versions for everything to work together. And just quickly, and everyone knows what an Xray data set is, but it was like my first time using it, but it was really cool. And hopefully I can also spread this knowledge onto my group back at FSU for the ones that use Python, because this was pretty cool how this is like all put together. But with using Xray data sets, it's really cool how you can package all of your information into multidimensional arrays. And then within the notebook, looking at the image to the right, you can look at everything in this cool interface, all of your information, coordinates, variables, indexes, attributes, all of it in one place. And with however your workflow is, figure out like which variables you want to extract and work with. Yeah, I think that's pretty cool, and that was really fun, like learning how to use this data set along with how to do some cool 3D graphics with it. So let's get into some examples that I provided. So throughout my time here, after doing all of the install and making sure everything works, I was able to put together 3 notebooks with their own data sets and kind of go through exploring like basically how to use PyVista and then compare it to something that everyone already knows how to use, Matplotlib. So with my first example, I just pulled like a data set. I think it was a global 1 degree for this one. And just went through showing like how to do like a simple 2D plot and 3D plot, both using Matplotlib and PyVista. And so for this one, you can see, yeah, with Matplotlib, just like a simple 2D plot, X and Y axis, you have a nice color plot, color bar, excuse me. And then with PyVista, same thing. You have your X and Y, you have your 2D image here, nice color bar, and then you can change the perspective how you're looking at the image depending on what axis you want to highlight. And inside of the notebook, even though it's 2D or working with 3D, everything is already interactive. Like with PyVista is already built in. For you to like rotate it around, look at it from different angles. It's a whole toolbar up here that pulls down once you're like messing with it to just do all sorts of different interactive things, exploring your data. And then same thing with Matplotlib, doing just a surface plot on the temperature data. You can see the same thing with PyVista, making a cool plot. You can see everything with the z-axis, your elevation, depending on the temperature and everything. And then that's color bar, and same thing, built-in interactivity where you can spin it around, look at it from a different angle, all sorts of stuff already built in with PyVista. And so with my second example, with using atmosphere science data, I wanted to get into like vector plotting. So with vector plotting with Matplotlib, it was really fun. Trying to find an easy way to present the data. First doing a 2D plot of wind speeds for this data set, and then using a UMV component of the wind to plot the vectors on top of the 2D plot. Something I'm usually doing is like quite easy, but then with PyVista, you can do something where you can create like a terrain of your area that you're looking at, and then put apply the vectors on top of that plot of the terrain, and then have like an interactive look at your data. And last example, I wanted to dive more into 3D representations of topography. So with Matplotlib, so using the surface function, you can present your data, and it's just looking at ocean data set with mean period of swell waves. And Matplotlib is infinitely configurable. So you can do a lot to make it interactive and make your data look good, but like just doing like a quick surface plot of your data, this is how it would look. So like would just take more time to get like a good terrain plot. Not that Matplotlib is bad, but it's just like with comparison to PyVista, like this took like the same amount of time and you get like a cool 3D plot. You see the X, Y, and Z axis and everything, color bar, and yeah, get everything in the same amount of time. And then you can also expand your structure grid to in the Z axis to be able to look for your plot to look like this, and which I think is pretty cool. And it's just like an easy tool to like have depending on your workflow and how you want to present your data to your viewers. PyVista is something to consider. And then, so here's just a comparison of both, just all together. So overall, Matplotlib, it is interactive, but it can take more time and it can be a little tricky to implement that interactivity. but overall, Matplotlib is easy to work with. It's easy to use. Like everyone uses it. And then with PyVista, the interactivity is already built in with every plot, 2D, 3D, like whatever you're working with. And most things are fairly easy to use, whether you're doing just like simple plots, charting, maybe with vectors can be like a little bit more tricky to use those, and applying like polydata and glyphs on top of your plots and everything like that. But it's a really cool tool. And then the bottom table here is just looking at the wall time for each thing. So for each example, the wall time comparison with Matplotlib and PyVista. Some things Matplotlib is faster at getting it done, and some things that are more involved, PyVista is faster at getting it done. It just depends on like what you're looking for your workflow. And next, I took a look at Rapids. So with like working with GPUs, it's like really fun. And so with Rapids, it's like a new open source software libraries and APIs that give you the ability to execute end-to-end data science and analytics, just like some of the similar things that you already use, like pandas, scikit-learn, scikit-image, GeoPandas. So Rapids has all of the same libraries and APIs that allow you to do the same thing in those packages, just like faster with using a larger data set. And then I just wanted to show this image showing like the breakdown of how Rapids is, the hardware, how everything is like the workflow is set up on top of using NVIDIA CUDA for parallelization and NVIDIA hardware. And then quickly moving on to installations. So just like to add on to that point. So like with installing, you need to have like NVIDIA Pascal GPU or better. This is a list of operating systems that it works with, and you need the recent CUDA version and NVIDIA drivers to work with it. And then same thing as PyVista, you have two pathways to install it, Conda, which probably would be the easier one to deal with, and then pip install. So this one, Rapids did give me a lot of like headache trying to get it installed. Had a lot of issues with the CUDA packages. Because one thing is that CUDA, well, NVIDIA just updated the CUDA toolkit to version 12, but Rapids so far only works with up to the CUDA toolkit version 11. So if you're a person that keeps everything updated like I do, you have to revert back to something that it can work with. And same thing with the versions of Python and everything. So working with Conda and Anaconda will be an easier route, depending on your workflow. I even opted to create a Windows subsystem for Linux on my local machine. Did get it to work, but some of the times logging on, sometimes it will work, sometimes it wouldn't work. So it's just like having to go through everything to get it set up on your machine. If you can get through that, this will be a good package to work with if you have like really large data sets and you want to utilize CUDA and parallelizing your work to get it done faster. And then another alternative installation is they do have a Google Collab Notebook that you can use to help you install everything. They have most of the packages that you will need, like data frame, machine learning, graph, spatial. All of these are already in there to be installed. It's a good alternative, but the installation does take a long time to get through before you can actually do some work on it. So, but it is good. So you already have everything you need, dependencies, everything there in the cells for you to get installed, but it just takes quite a while to get through the installation. But overall, my key takeaways when it comes to Rapids is that realistic data can be large and complex, and having a software library and API that can keep up with the data science is crucial. And just a comparison over here when it comes to the speed up, the CUDA data frame package compared to Pandas, you can see a 15 times speed up doing it, working with the complex workload. But if you have something smaller, if you're not working with like a lot of gigs of data, Pandas is very well maintained and works well, and it's getting faster every year. So it just depends on like how much data you're working with and how efficient you want to be in your workflow. Kind of like way in between the two. And that's it for Vista and Rapids. And these are just some of the references that I used for the install. So just the links to the sites for Vista, Xray, and Rapids. And then they also have like a lot of cool examples that you can work through that if you're not, you know, be a little rusty in Python and doing like plots and visualizations with it, working through these examples was really helpful. And then also applying it to Xray data, that was really helpful as well and really fun. And then same thing with the examples on the NVIDIA site for reference. And so I just want to say thank you to Thomas, my mentor, and Drew. Very helpful helping me with the notebooks, even though I had times where I was like, Thomas, I don't know what's wrong. It's not working and stuff like that. And then thank you to the Science Gateway team, making sure I had access to Jupyter Hub, because there were times where I was like switching between the Jupyter Hub, my local machine, just trying to get something to work. Thank you guys. And thank you to the UCAR and Unidata staff. One thing I was worried about with this internship was that I was the only one that was remote, but meeting all of you guys throughout the meetings, throughout the summer, like made me feel like so welcome, even though I'm like all the way in San Jose. So it was really fun to work with everyone. I learned a lot. I loved all of the workshops. Python, Python Pythia, like everything, learning how to make a cookbook. And I'm really excited. Like every meeting I've had with my advisor, I've just been excited to apply these things at FSU with other students who would probably could use this information and everything. And also like in our summer coding camp for Python, that we can also have a cool way to show them how to use Python as well, beyond like some of the stuff that we already do. So thanks everyone. That's my presentation. Do you have any questions?
Just a comment. I feel your pain as far as dealing with CUDA software. It's a pain in the neck. It really is. But that's not a question.
Yeah. Yeah, I thought I was done from like my research using CUDA. Then for the summer, it kept on.